No? How are we going to use this knowledge of homogeneity in solving differential equations? Okay, so I will introduce first a theorem. Actually, dalawang theorem, two theorems. So, theorem number one, okay, states that if m of xy and n of xy, so these are coefficients of our differential equations, diba? Yung sa general form, are both homogeneous, and of the same degree. So we can, based on the definition, we can determine if they're homogeneous, and there's another qualifier. They must be of the same degree. Okay, because we can also identify that using the definition of homogeneity. Then, no, the function, then the function m xy over n xy. So they did a division, okay? Magdi-divide the function mxy over nxy is homogeneous of, okay, the resulting quotient of the division is also homogeneous of degree 0. Okay? So that yun yung nakastate sa theorem of degree 0. Okay? So let's apply that, no? Let's apply this theorem to a standard differential equation. So let's say I have a differential equation m xy dx plus n xy dy is equal to 0. And I have established by definition of homogeneity that both of these, no, both of these coefficients are homogeneous and of the same degree. Okay? So, ibig sabihin nito, class, you cannot apply this solution to a differential equation which is not homogeneous, and at the same time, the coefficients are not of the same degree. So, ito lang yun. You can apply this solution to those kinds of differential equations. Okay? So, I will divide. So, let's just go through the theorem and apply it to our differential equation. So, I will multiply nxy. Okay? And I should have mxy over nxy differential x plus differential y is equal to 0. Now, this division, no, will produce a new function, of course. Kasi nag-divide ka nga eh. So, it will produce a new function which is f of xy dx plus dy is equal to 0. Okay? So, a new function will result to a division. Okay? Will result to the division of mxy over nxy. Okay? And then I will introduce a new theorem. Okay? We know that the quotient of this division is, sabi, by theorem 1, the quotient is homogeneous and of degree 0. So remember that, because that is very important in our next theorem. So theorem number 2 states that if you have a function and if f of xy is homogeneous of degree 0, in x and y, then f of xy is a function of y over x alone. Okay? Y over x alone. So it means to say, if I will apply theorem 2 to our differential equation, no? If I will apply theorem 2 here, f of xy will become a new function, which is g of y over x. Okay? Dx. So this one, applying theorem 2, will become g of y over x dx plus dy is equal to 0. So to continue this, so I now have a new function, so to say, a new function, which is a function of y over x. And I could introduce a new variable. I could introduce a new variable v. Okay? Putting the substitution y over x is equal to v, and therefore I could use the substitution from this y over x. Now y over x is equal to v, then therefore v is equal, or y, I should say, not v, y is equal to vx. Okay, and to substitute for differential y, from y equals vx, I now have v dx plus x dv. Okay, so look at what will happen to our differential equation. I have g of y over x dx plus dy is equal to 0. Okay, y over x is v. So this will become a function in v. Differential x plus differential y is equal to v differential x plus x differential v is equal to 0. Okay? I now have here two terms which have differential x. So I have g of v plus v, those quantity, dx plus x dv. Now notice that this equation now, the equation that I have produced or I have simplified, can be solved by variable separable. Okay? If I will multiply, let's say I will multiply x times g of v plus v, this will now result to dx over x, differential x over x, plus dv over g of v plus v is equal to 0. Okay? So, meaning to say, no, what is the conclusion here? No, the conclusion is, if I have a differential equation, m of xy dx plus n of xy dy is equal to 0. I have this differential equation, and I have established that m and n are homogeneous and of the same degree. Then therefore, I could solve it using a substitution. Okay? Using a substitution, which is y is equal to vx, or I could also use x is equal to vy, whichever is more convenient depending on the problem. Okay? But keep in mind, if I will use y is equal to vx, then I should also use differential y is equal to v differential x plus x differential v, okay? And if I will use x is equal to vy, I should also use differential x is equal to v differential y plus y differential v. To continue, no? So if I have made those substitution, okay, I have made one of these substitution to my differential equation, I will result to a new differential equation which can be solved using separation, the technique in our first lesson, separation of variables. Okay, so I will just give examples on our next lesson. So that, but ito lang yun. That's it for now or for this video. So again, first establish, this is the first step, establish that you have a differential equation that has homogeneous coefficient and of the same degree. And then choose a substitution. Okay? And then after that, solve using separation of variables.